Good morning, everyone, and welcome. So, today we will look at the different elements, all right? And today it is important for you to know that elements they are everywhere. We can't escape them. They're found in our bodies, our world, our sun, and the entire universe. Now, if we look at this chart, we can see that we have many different elements found in our Earth's crust. And out of all of those elements, the one that we see most frequently is oxygen. Good job. Okay, and now if we look at the dry air, we can see that nitrogen is existing in large numbers, right? Whereas oxygen is only existing 21%, followed by argon and the other noble gases, and then carbon dioxide with 0.4%. We have already seen that elements are organized on a periodic table based on their what? Atomic number. Yes, very good. A brief recap is that the atomic number tells us the number of, yes, protons, all right, and it also tells us the number of electrons, all right? And of course, the word atomic mass tells us how, yes, it tells us how the weight of the atom, okay? It tells us the weight of the atom. So here you have a list of common elements and their symbols. One word that we're going to come across again and again is valence electrons. And what are valence electrons? If we look at sodium, we can see that it has one valence electron. And if we look at chlorine, we can see that it has seven valence electrons. What does that mean? Valence electrons are the electrons in the outer energy level of an atom. So all of those electrons in the last shell, those would be considered your valence electrons. Okay, and these electrons, these are the ones that are transferred or shared when they bond together. Okay, and another thing for me to tell you is that the valence electron is also equal to the group number. So whatever group the element is in, that is how many valence electron the element actually has. So the elements of the periodic table can be divided into metals. You know, metals found in group 1, 2, 3, and also the transitional elements. And then we also have these things called non-metals, which are found further right, okay? Groups 4 through 8 are your non-metals, okay? However, we also have something called metalloids, and these metalloids, they separate the metals from the non-metals, okay? And metalloids, these have both properties of metals and non-metals. A brief recap on some of the properties of metals. We know that metals are good conductors of heat and electricity. We know that they are shiny, they are ductile, they are malleable, okay? Whereas non-metals are poor conductors of heat and electricity, okay? They are not ductile or malleable, all right? And they are brittle and they break very easily. So this right here is your periodic table with all of the different series, okay? Alkali metals, alkaline earth metals. You have halogens, noble gases, transitional metals. You have inner transitional metals. Most often when we see hydrogen, we normally see hydrogen in group 1. Hydrogen has some very distinct characteristics. It is a gas at room temperature. It has one proton and one electron in its energy level. So it only has it only has one proton and one electron, no neutrons. Hydrogen only needs two electrons to fill up its valence shell. Next we have the alkali metals, which are found in group, very good, they're found in group 1. So these have different characteristics, all right? What are some of the characteristics, some of the properties of the alkali metals? Atoms of the alkali metals, they have a single electron in their outermost shell. In other words, one valence electron. Remember I told you that the group number is also equal to the valence number. So here, the alkali metals are in group 1, and hence they only have one valence electrons. Okay, some properties is that they are shiny. They are very shiny, okay? They are very shiny in color and they're easily cut with a knife. So although they are metals, they are very soft. And it's for this reason that you can easily cut them with a knife. However, all right, it is also important to note that these alkali metals, these are the most reactive metals. They react violently when you put them in water, right? And they are never found as free elements in nature. They are always bonded with another element. So they are so reactive that they can never ever be found free in nature. They are always combined with something else. Okay, so these alkali metals are very, very, very reactive. And hence, why? Why do you think they're so reactive? Good. They only have one electron in their valence shell. So because you only have one electron in your valence shell, you are going to be super active trying your best to see how you can get rid of that electron so that you can form an octet, a complete full valence shell. Okay? So when these alkali metals are burned in air, what colors are they going to produce? Lithium is going to give us which color? Looks like reddish. What about sodium? Yellowish. And potassium? Purplish. Good. So crimson, lithium is going to give us a color, reddish color that we call crimson red. Okay, sodium is going to give us a golden yellow color, and potassium is going to give us a lilac color when we burn it in air. These alkali metals are so reactive that, remember, we said they're never found uncombined in nature. So let's look. An example of this is something called potassium. Potassium reacts with water, okay? Potassium right here, and must be stored in kerosene. It is so reactive that it can only be stored in kerosene. So what does it mean to be reactive? What makes an element reactive? So an incomplete valence electron level shell is what is going to make an element reactive. So if an element does not have 8 electron in its outermost shell, it is going to be reactive, okay? All atoms except hydrogen want to have 8 electrons in their very outermost energy level shell. And this is called the rule of the octet. We want to have 8 electrons in our last shell. If we don't, we're going to react so that we do get 8 electrons in our outermost shell. Okay, so atoms are going to be bonding until this level is complete. Atoms with few valence electrons lose them during bonding. So if you only have like 1 electron, 2 electron, 3 electron, very little, you're going to be losing them during bonding because it's easier for you to lose them in order for you to form an octet. So when you lose them, you lose those 3 electrons, then we're going to remove that last shell and then you're going to have 8 electrons. So the shell underneath that will have 8 electrons and you will be happy. Atoms with 6, 7, or 8 valence electrons, what they're going to do is they're going to gain electrons during bonding because if you have 6 electrons, it's easy for you to gain 2 more to have 8. If you have 7, it's easy for you to gain 1 more to have 8 electrons in your valence shell. So that's what they're going to do in order for them to go ahead and form their octet. Okay? The fewer number of electrons that you actually have to lose, all right, the more reactive you will be. So if you know you only need 1 electron, you're going to be very reactive because you're going to try your best so that you can lose, that 1 electron. And if you have like 7 electron, you only need 1 more. So you're going to also be very reactive trying to see how best you could gain 1 more to form your octet. So now we have the alkaline earth metals, and these are found in group number 2. Very good. Now, some properties of them are that they are silvery gray, they are never found uncombined in nature, they have 2 valence electrons. Okay, remember, the group number is equal to the valence electrons, so group 2, 2 valence electrons. They are hard metals. So now we have hard metals with high melting points and boiling points. So these are not like the other guys who were soft. These ones are hard, okay? And they have, as a result, they have high melting points and high boiling points. Okay, so when we burn these alkaline earth metals in air, okay, these are the colors that we're going to get. Strontium is going to give us what color? What do you think? Reddish. Barium is going to give us, look like greenish. And calcium is going to give us reddish, orangey. So strontium, okay, is going to give us the crimson red, right? We saw this color already. Calcium is going to give us a brick red. Okay, that's the color of the red that it gives us, a brick red. And barium is going to give us an apple green color. So right between your metals and your non-metals, you're going to have what we call the metalloids, okay, forms a nice staircase. And these have both properties of metals and non-metals, okay, and we have silicon and germanium, okay, they're used in computer chips and solar cells. So now the halogens, the guys in group 7, all right, meaning they have how many valence electrons? 7 valence electrons. What does this mean? They're the most reactive nonmetals, okay? Halogen atoms, they only need to gain 1 electron to fill their outermost energy level shell. Okay, because they only need to gain one more, they're going to be the most reactive nonmetals, okay? So we've seen that the halogens gave us different colors. All right, they produce different colors. All right, we have fluorine, gave us a yellow color, chlorine green, bromine red, and iodine purple black. Also note, we really don't care about the density, but look at the reactivity of the halogens, how they are decreasing. Okay, look at how they are decreasing. All right, can you predict how they increase? Okay, how the reactivity of halogens increase? So now we have the most unreactive group in the periodic table, which is the noble gases. Okay, noble gases, they are colorless and they are extremely unreactive. Okay, why do you think so? All right, they're inactive because their outermost energy level shell is full. So if your energy level shell is full, why are we reacting? We have no reason to react, so we're not going to react. We already have a full octet. Everyone else is competing, they're reacting, trying to get like us because we're full, we're stable, okay? We're stable. So now we have this section here in the periodic table, which are known as the transitional elements, okay? What is so important about them is look at the colors that they produce in solutions. They form brightly colored compounds. Okay, and the OG here is copper. Now, copper, when we burn copper in air, copper is going to give us this beautiful blue-green color.